Okay, today we're going to be working with the volume of cylinders. So the key idea is that the volume of a cylinder is the product of the area of the base and the height of the cylinder. We all know that the area of the base of a cylinder is a circle. So in place of this capital B, we could use this formula. Pi r squared gives us the area of the base. And at this point, our dimension becomes two-dimensional. So the unit would become squared, right, if you just did the area of the base. But to that, we are going to multiply by another dimension, the height. So when you're getting volume, it's a three-dimensional quantity, and our units will be cubed. So let's look at an example. To find the volume of a cylinder, and then round your answer to the nearest tenth. So using the formula, of course they're still using the capital B for area of the base, we know that the radius is 3, so pi times 3 squared times 6, or 54 times 3.14, which is approximately 169.6, and here's those units, cubic meters. So it's very, very important. And here they're showing you again the volume formula that I just wrote, pi r squared height, and this will deal with all cylinders because it gives you that area of the base or the circular component. Sometimes the missing dimension is the height. And so in this case, we're going to find the height using a little bit of algebra. So when we get to, let's see, this stage right here. So we have the volume. It is equal to, and then if I take 25 times the 3.14, I go ahead and multiply that in. I get 78.5, so 78.5 times the height, okay? All I've done is multiplied 25 times pi. At this point, we are solving for h, so we want to undo what's being done to it. It's being multiplied by this 25 pi, or 78.5, so I'm going to divide both sides by that amount. Okay, that cancels. When I take 314 divided by 78.5, I get exactly 4, about 4, and then the unit dimensions would be inches. So when I divide this, this is equal to 4 inches. And the reason that our side length is not, it's a one-dimensional quantity, right? Think about what the unit needs to be in order to be the height, because we have our diameter of 10, which makes a radius equal to 5. We square that, we get inches squared times another dimension, we get cubed, and that's where this inches cubed comes from. Okay, let's give it a try. So we either want to find the volume or the height. And in the first one, the missing piece is the volume. So we see a radius right here. We see a height up at the top. So using the formula, volume equals pi r squared height, we'll use 3.14. R squared would be 4 squared, and then our height is 15. So 3.14 times 16 times 15. And when you multiply that out, and it does say round to the nearest tenth, you would get 753.6 feet cubed. So it is okay to bring in the unit label at the end, but do not forget it. For problem number 2, working with the same formula, we are now going to substitute in a number for V. So we get 176 is equal to 3.14, and here we're given the diameter, so we have to divide by 2 to get the radius of 4 centimeters, so 4 squared times h. So when you take 3.14 times 16 times h, you get 50.24 for those, the product of pi and the radius squared for the area of the base. So we will divide both sides by our 50.24. And we will get 3.5 centimeters is equal to the height. Knowing that by dividing by this, it cancels that out, and we're left with the height dimension by itself. We've isolated the variable that we've needed. Okay, in this next example, it's a real-life application. We talked about some real-life applications of using volume yesterday, and one that wasn't mentioned at all was the volume of a water cooler, or possibly even a water tower, or things of that nature. So we want to know how many gallons of water this water cooler bottle would contain, and we're going to have to make a conversion because the dimensions they give us are in feet. So using the formula and calculating the volume in feet first, we know that if the diameter is 1 foot, the radius is half of a foot, right, or 0.5 feet. So that's the amount they used there. So they've calculated about 1.3352 cubic feet. Now we have a conversion factor. This conversion factor can be written as a ratio, or I guess you would call it a fraction, and we'd be multiplying that to it. Knowing that what you're going to do, it's a fraction equal to 1. So we could have 1 cubic foot over 7.5 gallons or 7.5 gallons over 1 cubic foot. And we want to use it this way so that we can cancel out the feet cubed, the cubic feet, and end with gallons. So in essence, we are multiplying 7.5 times our volume to get the final answer of 10 gallons. That puts us for answer B above. So we'll give this a try. If we have a water tower with a diameter of 15 meters, right, that already tells us that we know that the radius is 7.5 meters. And a height, about how many gallons can it hold or contain, and we have our conversion factor. So starting with the formula, pi r squared height, 3.14, 7.5 squared times our height of 5 from the information given, that we would get our volume equal to 883, and it didn't say anywhere where to round, so I'm just going to leave it now until we do our conversion. And again, we have this 1 cubic meter over 264 gallons, or 264 gallons over the 1 cubic meter, and oops, that's not a cube. And this is the one we want to use because it will cancel out. So when we multiply this by 264 gallons over the 1 meter cubed, the meters cubed will cancel. So when we multiply, we get 233,145 gallons of water in that water tower.